All right, let's go over these for ball work. The first three were in slope-intercept form. So for these, you should have just started at your y-intercept -2 for the first one, slope of 3, so up 3 over 1. And then you just connect those there with a line. And so all of the first ones were like this. All right. The second one, you had a 0 y-intercept, so that's just right here, and you had a -1 slope, so down 1 over 1. You didn't have to graph this. You could graph on different ones. The next one I actually told you to graph them all the same. And then the last one, you have a y-intercept of +4 with a slope of -1/2. So that's down 1 over 2. So your three graphs for the first one should have looked something like this. If it's going to let me move it. Oh. It's not going to let me move it. Should have looked like this. Easy enough. The second three were in what form? Yeah, so those were in standard form. So for those, you can do your intercepts if you want, which is fine. Or you can put it in slope-intercept form. It's completely up to you. If you put it in slope-intercept form, it may be easier to see what they're asking here. So for the first one, slope-intercept form would have been y equals 2x minus 1. The second one would have been y equals 2x plus 1. And the third one would have been y equals -1/2 x plus 1. All right. So those would look something like that. And so you can graph those exactly the same. What you're going to find with these is the first two are going to have the same exact slope. So what type of lines are they going to be? They're going to be parallel, right? So these guys are going to be parallel when we graph them. And then what about that third one?
It's perpendicular.
It's going to be perpendicular. Now, hopefully you remember from geometry. How would you know that? Those do not look parallel, do they? No. Up 2 over 1. I don't know. I must have just like tilted it a little. How do we know just looking at it that it's going to be perpendicular? Negative reciprocal. And so when we do this last one here, it's going to hopefully look somewhat perpendicular, but you know, human error here in graphing. So from geometry, hopefully you remember that negative reciprocals mean perpendicular, same slopes mean parallel. And so this whole section is solving by graphing. And so we've been doing linear equations where you, even with the word problems, you set up this, you solve whatever, just from your tests. And now we're going to throw in 2 linear equations. So we're not just going to have 1 linear equation, we're going to have 2. And so the very first method of solving a linear equation is to solve by graphing, all right? And really what they're looking for is they're looking for that point that works for both graphs. So they're looking at these 2 linear equations, and they're going to say what point works for both of them. What is an answer for both of them? The line itself is an answer for each one individually. So the thing that works for both of them is going to be where those lines intersect. So there's going to be a point where they intersect, and they will work. And so we're going to graph these based on that. Now, it doesn't matter how you graph them. You can graph them by your intercepts, or you can graph them by slope intercept if you want to. But what you need to make sure is that you know how to graph them either way. I will say for this second one, graphing by intercept is not really going to help you because you're going to find that it goes through the origin. So you're not going to have 2 points if you graph with intercepts for that one. So for these, we're actually going to put it in slope intercept form, even though it'll still be a little crazy to graph with that -7 there. So let's look at this one. We have x plus 2y equals -7. And so if you wanted to put that in slope intercept, you would need to subtract the x over and divide by 2. So it would be y equals negative 1/2 x minus 7/2. That's what happens when we put this in slope-intercept form. Subtract your x over, divide everything by 2. For this next one, it's not as difficult because we just have a 3y and a 2x, so you can just add 3y over. And so we have 3y equals 2x. And then divide by your 3. All right. So how do we graph it? We're going to graph it just like we did that first one, right? For the red line here, we have negative 7/2, which is where on my graph? Where is negative 7/2? Negative 3.5 right here. All right. And my slope is negative 1/2. So down 1 over 2. Down 1 over 2. All right. And then the second one, where's my y-intercept for that second one? The origin. That's why you wouldn't be able to do that with intercepts, because you wouldn't have 2 points. All right. So we have it at the origin. All right. And then my slope is up to over 3. Now for this one, I know it's not going to cross up here. So I would actually walk it down if I were doing this one. So I would say, yeah, I do have up to and over 3, but I can also go down 2 and left 3. And so that's going to tell me about where they're going to cross there. So if you don't see where they cross, just keep walking it until you can see where they cross. And that will help you be more exact. And you can even see when I graphed this one that it was a little bit down from here. We're going to say that this crosses the graph at this point right here, which is negative 3, negative 2. But you can tell from graphing that human error can happen when you graph. I mean, I'm using a measuring device, to keep a straight line. It still doesn't matter. You could potentially draw it wrong, especially when they have something like 7/2 when I'm estimating where this one is. And so for this one, my final answer is actually going to be that point, negative 3, negative 2. So what does this tell me? This tells me that negative 3, negative 2 is going to work when I plug it into this one. Negative 3 for x, negative 2 for y. And it's going to work when I plug it in for this one. Negative 3 for x, negative 2 for y. So what that's telling me is I found the answer that works for both of these linear equations. So in a word problem, you'll have 2 types of linear equations and you want to figure out what works for both of them. So you would set up 2, just like you did on your test. You set up 1 linear equation and solve for some type of answer. You would set up 2 and figure out what answer works for both of them. And so that's what this graph is telling me. Where they cross is what point works for both of these linear equations. So go ahead and try just one of these graphs. Check understanding number 1. Graph it and check your solution. So you have 3 possibilities when you solve systems of equations. The first possibility is that they intersect. We know from geometry that lines intersect at exactly 1 point. That's just a postulate of geometry. So if they intersect, you are going to have one and only one answer. The other possibility is that they end up being the same exact line. If they're the same exact line, then you have an infinite number of answers. The entire line is your answer. So if you have 2 equations, and when you graph them, they end up being the same thing, which you will see if you put them both in slope-intercept form, by the way, then there is no one solution, and the entire line ends up being your solution. And then the other option is you could end up having parallel lines, which means you have no solution whatsoever, because they never cross. So there are never any coordinates that will work for both of them. One solution is called independent. When they are the same line, it is called dependent. And when they are parallel lines, it is called inconsistent. Those are the types of answers you could potentially get. Now, if you put them in slope-intercept form, you will likely be able to tell that this is going to happen. All right, so let's look at these, classify these systems. Well, let's look at the example that they give us. We have y equals 2x plus 3. And we have negative 2x plus y equals 1. So what I am going to do is I am going to put them both in slope-intercept form. The first one is already in slope-intercept form. So that's already in y equals mx plus b. And then I am going to put the second one in there, which means I'm just going to move that x over. Y equals 2x plus 1. What do you notice about your slopes? They're the same. So what type of lines do I have here? Parallel. One thing you need to be careful of, same slope but different y-intercept. If they had the same y-intercept, it would be the same line, okay? So parallel lines here means that I am going to have no solution. No solution, which means it's going to be an inconsistent. Wow, it's making me draw my thing there. It's going to be inconsistent. Once you put that one in slope-intercept, what do you find? What type of classification do you have? Independent. Your slope on this guy is going to be negative 3.
Our book has 15.
Your slope on this one's going to be... Second one, what we get?
The same line.
The same line, so it's dependent. And then the third one, hopefully, independent.